Hi everyone, welcome to LC Math. Today we'll be discussing the golden differential equation. So recall from previous videos we've talked about the golden ratios phi satisfying phi squared minus phi minus 1 equal to 0, which told us that phi is equal to 1 plus the square root of 5 over 2. Well, there is also another solution. That we didn't really talk about since we wanted to have a positive solution. There is a negative solution as well. If we looked at, which is 5, there's also a negative solution as well. 1 minus the square root of 5 over 2. It's negative, and it's called phi bar, or the conjugate of phi. And we want to consider an associated differential equation, or rather a differential equation that involves a polynomial that has this solution. I got this idea from the Flammable Maths channel. He did it, in my opinion, using a method that is not really the best method. He did state in the video that he was aware of the other method and wanted to use the techniques, but I thought they were a bit overkill, so I just wanted to show you the NSATS version, or the ordinary way. So let's talk about y double prime minus y prime minus 1 is equal to 0. Sorry, not 1, y. So we have the second derivative, first derivative, and 0th derivative of y being equal to 0. We're going to use the ansatz, or guess, y equals e to the st, and we're going to solve rest, see what happens. So this tells us immediately, well, I'll go ahead and write this down. You probably don't need this, but just for clarity, equals s e to the st. Then, of course, y double prime is going to be s squared e to the st. Excellent. Tells us immediately that 0 is equal to s squared minus s minus 1 e to the st. Since e to the s is always greater than 0, we can definitely just divide it. So this is just s squared minus s minus 1, which does have the solution. Has a solution here of s minus phi bar. Same thing. Now we can just go ahead and write down our solution right away. Yt is equal to some constant e to the phi t plus some other constant e to the phi bar t. Notice this video is pretty short and the original video was pretty long, so I mean, you tell me which method you prefer. I would always use this method. In fact, you can definitely use this differential equation to illustrate to people learning differential equations for the first time that you can have cool polynomials appearing when you have linear systems like this. And if you enjoyed this, want to see more, feel free to subscribe. I'll be seeing you next time.